Hi everyone, welcome back to the Statistics Lab, where we make statistics simple and fun. In today's video, we're diving into the concept of the two-tailed t-test with a real-world example. By the end of this video, you'll have a solid understanding of how to perform and interpret a two-tailed t-test when population variances are equal. So, let's get started. Imagine a fitness trainer wants to compare the effectiveness of two different diet plans over a 12-week period. Group A follows a low-carb diet, and Group B follows a low-fat diet. After 12 weeks, the trainer collects weight loss data for 15 individuals in each group. The goal is to find out, is there a significant difference in the average weight loss between these two diet plans? Here are the summary statistics. For Group A, low-carb diet, the mean weight loss is 4.2 kilograms, with a sample variance of 0.36 kilograms and a sample size of 15. For Group B, low-fat diet, the mean weight loss is 3.7 kilograms, with a sample variance of 0.25 kilograms and a sample size of 15. We'll perform a two-tailed t-test at a 5% significance level to answer this question. Ready? Let's break it down step by step. In step 1, we collected the given data. For Group A, the value of x1 bar is 4.2, the value of sample variance S1 square is 0.36, and the sample size N1 is 15. Similarly, for Group B, the value of x2 bar is 3.7, the value of S2 square is 0.25, and the sample size N2 is 15. The sample sizes N1 and N2 can be different, so do not get confused about that. The significance level alpha is 0.05. Okay, now we proceed to the second step. In the second step, we set up our hypotheses. Let the true mean weight loss for Group A be denoted by μA, and the true mean weight loss for Group B be denoted by μB. The null hypothesis, or H0, states that there is no significant difference in the mean weight loss of the two diets. This is denoted by H0, μA equals μB. The alternative hypothesis, or H1, states that there is a significant difference in the mean weight loss of the two diets. This is denoted by H1, μA not equals μB. Now, this is a two-tail test. If you do not know how to decide the tail of the test, you can put a comment in the comment box, and we will create a separate video on that. For now, you can remember that if the alternative hypothesis has a sign of not equals to, then this is a two-tail test. Okay, now we proceed to the third step. To test our hypotheses, we calculate the test statistic using the t-test formula. Before calculating the test statistic, the pooled variance is calculated first. The formula for the pooled variance, SP squared, is written here. The sample variances are multiplied by N1 minus 1 and N2 minus 1. In the denominator, we have N1 plus N2 minus 2. We can substitute all the values in the formula like this. After doing the calculation, we obtain the value of pooled variance as 0.305. Do not worry about the calculation, because mostly these calculations are done using Excel or a calculator. If you have to do calculations manually with your hands, you will be provided simple data to calculate. The main objective is to understand the concept, not the calculation. If you are able to understand the concept, please give a thumbs up to the video. Also, you can message us on Telegram if you have any other questions to solve. Now we have all the required values. One can put all the values in the formula of the t-test statistic. The formula of the t-test statistic is given here. We simply put all the values and calculate the test statistic. The value of the test statistic comes out to be 2.47. Again, do not worry about the calculation, because these calculations are done using a calculator. After calculating the test statistic, we draw a conclusion. The conclusion can be drawn using two methods. One is the critical value method, and the second is the p-value method. In this video, we will discuss both methods. However, any one of the methods is sufficient for drawing the conclusion. Next, in step 4, we calculate the critical value and compare the test statistic to a critical value. For this test, we're using a 5% significance level. With 28 degrees of freedom, the critical value for a two-tailed test is approximately 2.04. This critical value can be calculated using a t-table or the Excel formula. The Excel formula for the critical value is t.inv.2t, 0.05, 28. Hence, the critical value is 2.04. Now we draw a conclusion based on the critical value method. The decision rule says that if the test statistic is greater than the critical value, we reject the null hypothesis, and if the test statistic is less than the critical value, we do not reject the null hypothesis. For our data, the test statistic comes out to 2.47. Since 2.47 is greater than 2.04, we reject the null hypothesis. Now the question is complete. The conclusion has been drawn. The conclusion is that there is a significant difference in the average weight loss between the two diet plans. But the same conclusion can be drawn using the p-value method also. If someone is more interested in drawing the conclusion using the p-value method, then here we go. Step 5. The p-value method. The formula to calculate the p-value for a two-tailed test is 2 times 1 minus probability capital T less than the absolute value of small t. Here, capital T follows the student's t-distribution with 28 degrees of freedom. The small t denotes the value of the calculated test statistic. This p-value can be calculated easily using the Excel formula. The formula is t.dist.2t 2.47, 28. Using this Excel formula, the p-value comes out to be approximately 0.02. We have two things here. One is the p-value, and the other is the significance level alpha. The decision rule says to reject the null hypothesis if the p-value is less than alpha, and do not reject the null if the p-value is greater than alpha. Since the p-value is smaller than the significance level, we reject the null hypothesis. Therefore, both methods give the same conclusion of rejecting the null hypothesis. Finally, we write the conclusion or the interpretation. So the null hypothesis is rejected. Statistically, the weight loss of both diets is not the same. The weight loss is different when following different diets. At the 5% significance level, there is sufficient statistical evidence to conclude that there is a significant difference in the average weight loss between the two diet plans. Thank you for watching. If you found this video helpful, please give it a thumbs up and subscribe to the channel for more easy-to-understand statistics content. Have questions or want us to cover a specific topic? Drop them in the comments below. Message us on Telegram for any other questions. Until next time, keep learning and stay curious.